All right, in this section, we're going to talk about maximum and minimum values of quadratics. We know just from what a quadratic looks like that if it opens upwards like this, then we have a minimum value at the bottom of the parabola. And if our parabola opens downward, then that means we have a maximum value at the top of the parabola. So that's what this box says here. If a is greater than 0, that means the parabola opens up and we have a minimum value. If a is less than 0, that means it opens down and it has a maximum value. Remember, we've talked about before, an ordered pair is not an appropriate answer to a question about maxes or mins, because a max and a min has two different characteristics. Its location, which is the x value. That's why this sentence says f has a minimum that occurs at x equals whatever. And then it has a value, which is f of whatever. It is the y value of your function. And I've suggested this before, but I'm going to tell you again. You should memorize this sentence whenever it comes to maxes and mins. This is the best way to answer these questions. The max or min value is f of x equals blank at x equals blank. It tells you what the value is, and it tells you where it happens, at x equals blank. That gives both parts of the maximum and minimum without using an ordered pair. Put that on a flashcard, memorize that sentence, because those are the answers I'm going to be expecting to see. Okay? Now, if the function is called h of x or g of x, change it accordingly, or maybe it's y equals, change it accordingly. But that's how I'm going to expect to see your answers written. Okay, let's look at some applications here. Consider the quadratic function f of x. Determine without graphing whether the function has a maximum or a minimum. Well, remember, that depends on whether it opens up or down. Since a, which is the number in front of the x squared, since a is positive, okay, a is greater than 0, that means that the parabola opens up, which means that it has a minimum. Okay? Find the maximum or minimum value and determine where it occurs. Well, in order to answer that, we need to know the vertex of this parabola. So x is equal to, remember we use negative b over 2a. So the opposite of b in this case is going to be positive 16 over 2 times 4. So that's 16 divided by 8. That comes out to be 2. So that's where the minimum happens, is at x equals 2. What is the value? We need to figure out the y. So that's going to be f of 2. So this is going to be 4 times 2 squared minus 16 times 2 plus 1,000. You can put that in your calculator, and you should get 984. So we write our sentence. The minimum is f of x equals 984 at x equals 2. That's what I want your answers to look like. Okay? All right, now it wants to know the domain and the range. Well, the domain is easy. For quadratics, the domain is always negative infinity to positive infinity. The range is a little bit trickier without looking at the graph, but we have all the information that we need. We know that this is a minimum, which means our parabola opens up. And we know that the y value here is at 984. So the range is that we start at 984 and it goes up to positive infinity. And that's it. Okay. Let's look at a couple of applications. So projectile motion is a great application of quadratics. So this is one you definitely are going to want a calculator for. It says an archer's arrow follows a parabolic path. The height of the arrow, f of x in feet, can be modeled by f of x equals all that, where x is the arrow's horizontal distance in feet. What is the maximum height of the arrow and how far from its release does this occur? Well, we know that the maximum is going to come from the vertex. So that's the first thing that we have to figure out, is what is the vertex of this parabola. So I'm going to put this on pause and see if you can determine both of those parts. What's the maximum height? That's the y value. And how far? That's the x value. Pause the video. I'll be back in 3 seconds. All right, so using the x equals negative b over 2a, I get 200 for x, and then f of 200 gives me 205. So what that means is that the maximum height is the f of x value. So that's going to be 205 feet. And then how far from its release, that happens 200 feet from release. So when you release the arrow, it takes 200, I forgot my feet, horizontal feet before it hits its maximum height. Okay. B is a little bit different question. Find the horizontal distance that the arrow travels before it hits the ground, round to the nearest foot. So what we need to figure out is, what is the x-intercept? This, now how do you know that? Let's think about what this is going to look like. We're going to have our person standing here, shooting the arrow. And when we shoot the arrow, it's going to follow some path, and it's going to land. So we need to find the x-intercepts. Now there's probably going to be 2 and one's going to be negative. That means it's behind the person. That one doesn't make sense. This equation has weird numbers in it, so I definitely want to use the quadratic formula. So x equals negative 2 plus or minus the square root of b squared, so that's 4, minus 4 times negative 0.005 times 5, all over 2 times negative 0.005. And when we work that through in our calculator, once using a plus and once using a minus, we get 2 different answers. Go ahead and try putting that in your calculator now. Pause the video for just a moment and see if you can type that in correctly. So these are the numbers that I get. Be very careful with your parentheses in your calculator. Make sure you're setting it up just right. And if you're not getting these numbers in your calculator, make sure you come and see me when you come back so that we can make sure that you're typing this in correctly. So that means that this number right here is 397.48. Round to the nearest foot, that's going to be 397 feet. The negative one doesn't make any sense. We only need the positive distance from 0 to there, okay? Now it says go ahead and graph this. Well, we know that this graph has to go up to essentially 400, 397.48. And then we know that the maximum height is 205. So let's see how many boxes we've got here. We've got 5, 10, 15 boxes. If I do 400 divided by 15, that gives me roughly 26. So maybe I'm going to count by 30s. So this would be 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360, 390, 420, and so on. Now on the other side, let's see how many boxes we have. 5, 10, 12, and we need to get up to at least 205. I think that counting by 20s will work because that would make this 100 and that would make this 200, and that's going to be just plenty. Now let's make sure we label our graph. The x value is the horizontal distance in feet. Horizontal distance in feet. And the y-axis is your vertical distance, again, in feet. Okay. The easiest way to graph this, we already know where the vertex is. It's at 200 and 205. So 200 is going to be a little bit before the halfway mark between 180 and 240, and we need to go up to 205. This is in no way perfect because we're not using a computer. This is just a rough sketch, so it might be something about there. We know that it hits the ground at 397, so that's 390. 397 might be somewhere right here on the x-axis. And then we know that we have an x-intercept that's negative. So let's look at the y-intercept. If you plug in 0 to this function, f of 0, we get 0 squared plus 0 plus 5. So 5 is the y-intercept, and that's going to be somewhere very close to 0. So the graph looks something like that. That's not a great parabola, but you get the idea. Okay? Just a couple more examples real quickly of how we can use parabolas then to solve equations. Solving equations. Okay. Let's look here. 2 different types of word problems. Among all pairs of numbers whose difference is 9, find a pair whose product is as small as possible. So let's think first about a pair of numbers. If I have a pair of numbers, we can call them x plus y. Well, x and, we don't want plus, sorry. If we call the numbers x and y, it says their difference is 8. So that means x minus y has to equal 8. Now we need to write an equation regarding their product. So if we let x equal the first number, then does it make sense that if I take this equation here and add y to both sides, that gives me x equals 8 plus y, then I can subtract 8. So that tells me that y is equal to x minus 8. So that means that x minus 8 is the second number. Okay. The question we want is we want to find the maximum of the product. So we need to write a product function. Let's call it P of x for product. That's going to be x times the second number, x minus 8. That's what we want to solve. So in order to do that, we need to find we're not actually trying to solve this because we don't know what it's equal to. We're trying to find the minimum, which means we either need to use vertex form, which this is not, or standard form, which this also is not. But if I distribute, I get x squared minus 8x, and that is now standard form. So to find our vertex, we use negative b over 2a. Okay, so this is your bx term. C is 0 in this case. We don't need c anyways. But so b is negative 8, so the opposite will be positive 8 over 2 times 1. So x equals 4. Now, we don't actually care what the y value is, but that's going to tell us what our product is when x is 4. P of 4 is going to be 4 times 4 minus 8. So that's going to be 4 times negative 4, which is negative 16. So what are the two numbers? Well, the first number is 4. The second number is 4 minus 8, so it's negative 4. And the minimum product is going to be negative 16. So there's our answer. This idea of you can start with 2 variables, but we have to get our function to only have 1 variable. So that's why I used this relationship to figure out what y is by itself in terms of x. So essentially what we did was we know the product is x times y, but it's kind of like a system of equations. Now that I know what y is equal to, I can replace it so that my function only has x's in it, which is what we want to do. Last example, number 7. You have 120 feet of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? So we can think of this again using 2 variables and then convert it down to 1. So let's think. We have a rectangle like this, and we know that we have the length, we'll call that x, and we have the width, we'll call that y. They told us that this function, that this fencing area, I only have 120 feet for the fencing. So that tells me that the perimeter, 2x plus 2y, has to equal 120. The area is going to be x times y. Well, we can't have 2 variables, so we come over to this one and we solve it for one of the variables. I'm going to solve it for y. When we do that, we get 60 minus x for y. Knowing what y is now, that allows us to write this as a function of x, because it only has x as a variable now. So that's going to be x times 60 minus x. Now from here, you're going to do this just like the other one. Multiply it out, find the vertex, and that'll answer your question. So pause the video one last time, see if you can finish this. Come back in 3 seconds for the final answer. All right, you should get 30 for x, and so that tells us that the length is 30 feet, and then the width, y, is 60 minus 30, so that's also 30 feet. And when we plug that into the function, we determine that the maximum area is 900 square feet. So that's just a couple applications of quadratics, and that'll get you done for today.